Okie dokie. Well, let's see. We are moving right on into February. It's the 9th already. So Valentine's Day this weekend. We're going to be halfway through the month by Saturday. So we're just zipping right along. It means we only got like 5 weeks till spring break. Seems like we just started the semester, but then I don't know. It'll get there. Let's take a look at our software development for the week. Should have the 4.01, 2, and 3 all completed by this point, which I'm pretty sure everyone does. So we have 4.04, and then probably have a discussion-based assessment next week where we'll just chat and see how things are going for the semester, and then we'll have a test the week after that. So 4.04 data exercise. Let's go see what data we're exercising. Programming inspired by nature. What do the natural world and computing world have in common? A lot, actually. Programmers often look to natural phenomena for inspiration when developing algorithms. So let's see how they define that. Events not engineered by humans. Okay, I can take that definition of natural phenomena. That's because these type of events present the unique combination of rules and randomness. Let's take a look. The aurora borealis. Solar wind is constantly being emitted from the sun. So when it interacts with the Earth's atmosphere, it creates these random displays of vivid color. Artists are very excited about that, right? Application. NASA uses computer programs and satellites to give advance warning of geomagnetic storms, which are caused by solar winds. So they kind of monitor all of that and let us know when there's going to be some chaos with the geomagnetic storms. Bee swarms. Bee swarms are pretty interesting. Honeybees live and work in highly organized hives. Sometimes the bees will randomly relocate. They'll swarm to a new location up to a kilometer away. Just suddenly they'll pick up and move. Computer programs can evaluate animal behavior, which can be useful when tracking and monitoring environmental markers like the number of bee colonies, which are very, very important. So I remember when I was a teenager, there's a hive of bees just moved into our front yard. I went out there, I heard some buzzing. I look up, and up in the tree is a huge swarm of bees. And I'm like, oh my goodness. We had a friend who's a beekeeper, though, so he came and got them for us. But yeah, it looked just like that, hanging from the tree. It was just a big, big bunch of bees. Human intelligence. Is that a natural phenomenon? Wait a minute. Some regard intelligence as a natural phenomenon of the human brain. This explains why attempts to create convincing artificial intelligence are so difficult. And boy, is it difficult. AI is just not that smart sometimes. Artificial intelligence software is at work in applications such as virtual assistants, voice recognition, software, robotics, and online ad delivery. Oh, yeah, a moment from the Super Bowl last night. So we're watching, and Pepsi ran a commercial, which Pepsi hadn't done a lot of advertising in the Super Bowl of late that I can remember. And I'm like, wow, they must be desperate since their sales are dropping. So I opened up an AI, and I just asked AI, I said, okay, what is the ranking of soft drink sales? And it said, well, Coca-Cola is the most popular. And it's like, yeah, they have been forever. And it says, followed by Pepsi close behind. And then it listed their soft drinks. And I said, no. I said, last year, Sprite passed Pepsi and Dr. Pepper passed Pepsi. And then it says, well, last year, Dr. Pepper and Sprite did indeed pass Pepsi. Pepsi is the number 4 most popular soft drink. And I'm like, why did you just tell me it was second? So it's like you have to correct AI all the time. It's like, it's not second, it's 4th. So crazy. Lightning strikes. Physical science tells us that lightning is caused by electrostatic discharge. However, the path and the shape of lightning strike is random and is never duplicated. So computer programmers can use sensor data to monitor atmospheric changes and predict lightning storms. Lightning storms can be just vivid. Go crazy out there. So learning from the natural world. Events in nature never happen the same way twice. By studying natural phenomenon, programmers can analyze and find patterns in the way that these random events happen in the natural world. Those patterns can be used to develop programs that can make educated guesses at unpredictable situations. forecasting a hurricane's path, identifying the next strain of flu, predicting performance of the stock market, and more. You know, they say these things never happen twice, but there's a story out there about a guy who's been struck by lightning 7 times or something. It's like chances of getting struck by lightning once is not that great. But analyzing natural phenomena. So understanding natural phenomena often means working with large collections of data. Oh, sure. The more data you get, the more accurate your predictions can be. So that's because the more data you have, the better predictions you can make. The first step is working with large amounts of data is sifting through it all. What have I got? What's all this data? What do I have? Programmers start by using different types of search algorithms to help them comb through these large data sets. Let's see how these search algorithms work. Okay, is there something to click here? No, this is just a bunch of stuff. We got spreading. I think that's supposed to be diagnosis, but that's a terrible spelling of diagnosis. Diagnosis of diseases, water stress, field monitoring, the variable rate of fertility, soil erosion, smart data, crop yield analysis, all of this electronic stuff. All right, so a linear search algorithm. This is one way to go through our data. When you need to find an item in a list and the data is in no particular order, choose a linear search. So it's a sequential search made over all items one by one until a match is found. So it just starts with the first one and looks at every piece. With this type of algorithm, Python will begin searching at the beginning of the list, index item 0, and will continue to check each item in the sequence until a match is found or it reaches the end of the list. So here's an example. Oh, let me see. Does this have sound? No. So it's searching each one. It's looking for 37. So it starts with number 1, 3, 5, going through searching each. And this is just prime numbers. The 11th item on the list. Took 11 steps to get there. But it's searching through all the prime numbers to find 37. It just starts at the beginning with a linear search. So, all right. Then there can be a binary search algorithm. If your data is in a sorted list, which this actually is a sorted list from smallest to largest, so we didn't have to do linear, I guess. A binary search is a more effective choice. So it's a search algorithm that finds the position of a target value within a sorted array. So using this type of algorithm, Python checks the value in the middle of the list first. Okay. If your search value matches the middle number, it's done. Its position is returned. If it's greater than that, then it'll begin searching in the upper half or the lower half of the list, depending on what that middle number is, eliminating the other half. Python continues in this manner until your search item is returned. So let's see the example here of a binary search. It's going to jump to the middle. Checks the middle number first. Oh, it's got to be higher than that. So it goes to the middle of those numbers. Oh, got to be lower than that. So it only took 3 steps this time to get the number instead of like 11 before. So if it knows it's in a sorted number, it's not random. The numbers are sorted from smallest to largest. That's a pretty quick way to find things. Just go to the middle and see, do I need to go which way from the middle? So that's pretty cool. I like that. All right, let's look at page 3. Simulating natural phenomena. Blizzards, tsunamis, forest fires, zombie outbreaks, well, whatever that natural phenomenon is. When disaster strikes, it often involves natural phenomena. However, simulating natural phenomena doesn't need to be so life-threatening. In reality, programmers use this type of simulation to answer questions, understand, and predict a variety of events, both ordinary and extraordinary. So designing a simulation. Before you jump into coding, start with the facts. For example, we'll be analyzing data about the U.S. minimum wage and the average college tuition prices. So armed with data, you can begin working through the steps of computational thinking. Let's get started. Okay, so the problem. First, you have to identify the problem, right? With computational thinking, what we're talking about this semester here. Ask a question. Think about what data you have. What kind of questions could it answer? Example, in 1980, how many hours did a person need to work at minimum wage to earn enough to pay for 4 years of college? And how that changed 30 years later in 2010. Okay, so We've got all this data. That's a good thing that we can analyze. So that's the problem. So the decomposition, breaking it down, what data do you need to answer that question? How are you going to find it? What variables need to be examined? So for this problem, you'll need to know what the minimum wage and the average cost of a four-year tuition is in both 1980 and in 2010. That's what we need to know. We're going to compare those items. So pattern recognition. Look at the data. Do you notice any trends in the data? As the years go up, do the minimum wage and tuition costs go up or down? Well, I would pretty much guarantee they're probably going up, both of them going up through the years. How significant are the changes? How can you use these trends to write code that will help you analyze the data? Now the algorithm design. Start with the pseudocode. Since there's a lot of data, let's use a linear search algorithm. Just look at every piece until we get to the information we need. We don't know for sure how our data is sorted, so this will be easiest. That'll help us easily find the specific variables to answer our question. So the pseudocode below, right here, searches for a variable within the list and returns its position. Later, we can translate this into Python code. So first thing in our pseudocode, set the variable found to false. Because we don't even know if the information's in the data. So we're going to assume it's not there. Loop through each item in the list, starting with the first item to the last item. So we're just going to do them in order. If the desired item and value is found in the list, print or return the position of where it is. Let us know which data number. So if we find it, then we'll be sure to print that out or save it. Break. So, stop your loop if you find it. If the desired value is not found in the list, then print that we didn't find it. We didn't find any data for 1980, or we didn't find any data for 2010. Okay, employability skills, problem solving. Programmers never run away from problems. That's because solving them is their day job, literally. Think about it. The purpose of writing a program is to solve some kind of problem. In code, algorithms define a series of steps needed to solve a problem. And one of the best job skills programmers can hone is, you guessed it, problem solving. The more you solve problems, the better you're going to be. Pro tip, working through the steps of computational thinking can help you get better at solving problems too, not just writing programs. So what are you waiting for? Go find a problem to solve. Okay, not right now. Let's finish the lesson first. Simulation algorithm, putting it all together here. You've asked the right questions. You've broken down the data and you've examined patterns and trends. You've written pseudocode. Now it's time to take all your planning and translate it into a Python program. So before you jump in, let's see what a linear search algorithm looks like in code. So we'll select each rollover to learn what each line of code is responsible for. So here's our code. Define main. Years equal. And here's our list of years. And then here's the matching minimum wage. Matching minimum wage. Average tuition rates. So each of these have 4 items. That's good. So they all line up. 1980, minimum wage, average tuition. Print U.S. minimum wage and average 4-year tuition by year. Print some lines, just make a little fancy heading. X equals integer input, enter a year to search. So we're going to ask what year you're looking for. So here's where we did in our pseudocode, where found equals false. They take this Boolean variable, we call it found, and we're going to assume it's not there. For I in range, and we're making the range the length of our years list up here. If years I, because I is our counting variable, that's our loop that we use. If years I equals X, and X, remember, is the year we entered. So if the year is found, then change found to be true instead. Checks the item at position I matches year input. Change it to true, print the year was found at position, and we'll say, is it 0, 1, 2, or 3? Because there's only those four things. And then break, get out of the if loop, get out of the if. And then here, if not found, print, I'm sorry. Does this actually code if not found? Haven't tried that. Print, I'm sorry. Oh, I guess it's saying if, here's not if statement, not found. So found is not true, which means found would be false. If not is a command there. I'm sorry, this was not found in the list, main. So let's copy this into a window and play with it a little bit here. Open up our little idle. Let's run it. Enter your search. Let's say 1980 first. And it says, yes, this was found at position 0. So that's the first item in each list is the year 1980. Let's say 1987. Sorry, 1987 is not found in the list. How about that 2010 that we need to compare with? That was found in position 3. So this program just simply looks to see, do we have any data for the given year that we enter? So if not found, I like that. Hadn't used an if statement like that. We would do if found equals false, but you can do it this way to where if it's not true. So learning little shortcuts. Let's look at our Python guided activity. In this Python guided activity, you'll write code for a linear search algorithm and use it to analyze and understand data, make predictions. Searching lists in Python. Define main. Here's a list with Johnny, Jack, Jay, Joey, and Jenny. That's a lot of J's. And their ages. 2 lists. X equals input. Enter a name to search. Again, we're going to start saying, okay, we're going to assume the name's not there. But if you do find it in there, if it equals whatever the X is that we type, it's really a bad variable name. They should say name or something. Then make it true and print it was found at this position. If not found, sorry, it's not there. So this looks very much like the data we were just looking up ahead. But let's run this. Let's say James. That's a J name. Sorry, James is not found in the list. Jack. Jack is found at position 1. There's Jack right there. 0, 1, 2, 3, 4. And we're not doing anything with it yet. We're just seeing if it's there. Then you could pull up their age if you know that it's in the list. So let's see what they do on slide 2. So here's the same program, looks like, except what have we added to it? Oh, nothing. Are we supposed to do something? This is entering an age instead of a name. We're searching the age instead. And this says, for I in range, the length of the names, if names equals age. Oh, let's see what that's going to do. Because if I put like 15 is not found in the list. Because it's not searching the ages, it's searching the names. So we need to change this to ages. So if the ages, whatever item in the list, equals what we entered. Found it position 2. Oh, what do they want us to do? Test with 17. Okay, I'll put 17 then. Found the position 4. So yeah, I've got to make sure you're checking the right list because it was still looking for names, but it was having to enter an age to search. So, but that's a good way to test to see if some data is in there. You know, let's play with it just a little bit. Let's go back to finding the name. Names. Enter a name to search. And let's say if we find it, then let's do this. Print. Let's see. Oh, we don't need the string X now because we took out the number. Let's make it X. X. And then we're going to say is plus, and then we'll do ages I just want to see if we can pull up their age. Years old. Let's see. Is there anything wrong with there? X. Oh, I got to put a plus. X. X is the name because we're having them enter a name. We're going to search, is the name in the list? If it is, print their name and where it's found, and then say whatever their name is and pull up their age, which shouldn't be using the same number. We'll see if that works. So let's say Jack. Oh, something's wrong. Oh, ages. I got to use the string command. That's what we did wrong. Because that's a number. Let's try it again. Jack. No, I still have it wrong. Invalid literal for integer with base 10 on line 7. Oh, up here? Oh, I don't need integer now. That's the problem. We're entering a name, and Jack is not an integer. There you go. Jack is found in position 1. Jack is 16 years old. So it's like we want to do something. If we found his name in there, let's check his age since we have that in a different database. Because that's what we're doing. We're checking things and comparing it with other lists. So since we know he's in position 1, we can pull up position 1 of the ages and know, okay, so that is Jack's age. Because that may be useful in our program this week. We're about to look at our program. But Jack is found in position 1. Jack is 16 years old. We say Jimbo. That's another J name. Jimbo. Jimbo's not found in the list. Sorry. No Jimbo. All right, let's go. It says follow the assignment template. All right. I'm going to pull it up in our Google Classroom here. What is this week? 24. Oh, I didn't get. Oh, there it is. Like, where's the attachment? I didn't get it. There it is. Okay. And I did give the Boost AI Tutor if you want to use it. So let's look at the template. What are we doing this week? Now that you've seen search algorithms in action, it's time to show your instructor and yourself how to put it all together. So again, they're like the computational thinking model here. So step 1, the decomposition. This involves identifying a problem and breaking it down into smaller steps. Here's our problem. Example, you're part of a charity organization planning an upcoming sunrise 5K on the beach. So to pull it off, you'll need to find a weekend date and a start time that coincides with sunrise. Okay, sounds like a problem for programming. After the problem's been broken down in the decomposition step up here, we need additional data. So our pattern recognition, a quick internet search provides you with the data you need. Sunrise times by date organized into a CSV file that, like we talked about last lesson. What patterns should the data reveal? All right, here's where it gets to the fun part. You got 2 options. Option 1, I'd recommend option 1 because we don't even know what's in the CSV data right now. You need to pick a weekend date for a Sunrise Beach 5K for charity. On an ideal weekend date, the sun should rise at 6:45 in the morning, so runners can enjoy a sunrise view during the race. Write a Python program that analyzes the provided CSV data file. So this is a file that they go pull data from. It's a data file of sunrise times by importing here's the file, sun_data.csv. So I might need to go back to last week's to remember how to import that file. This has already been saved for you to use in the course idle. Ask the user to search for a specific date or piece of data that can be found in the list. Your program should print whether it's in the list or not. So we're going to take last week where we learned to import this data, and this week where we learned to search through data and check to see whatever the user enters on a specific date, and you'll have to tell them how to enter it. So we're going to have to import the file, look at the file, right? Use the last week's lesson to print out the whole file, look at the file on the screen, figure out what format the date's in. Does it say January 1st or does it say 1/1 or, how's it do that? So your program should just print whether or not that date information is there or not. Or if you want to think up your own scenario, as long as it uses that list of data. So you don't have to make it a race if you want to do something else where you're looking up these dates and sunrise times. But you have to use this sun data file and pull information from it and tell if something's there. So you could change the storyline, but we're still importing the file. Write your pseudocode. Should be written in the steps that reflect algorithm design. Here's the things your program should do. Print a description of the event. If it's option 1, it's a charity 5K. Ask for the user input, race, time, and date. Show proper use of integer, float, or string. Demonstrate the proper use of a linear search. Include a for loop, because you need the for loop to search. And provide output based on the input. It says, ask for additional user input based on the results of the linear search. So if a search to race time appears in the data set, you can ask the users if they want to schedule the race for that time. Okay, so it has a little extra piece there. We found the time. Would you like to schedule to run at that time? So the output could look like something like this. Welcome to the 5K Race for Charity. We're a not-for-profit organization that specializes in helping those in need. And so obviously at this point, there was an input. What time would you like to schedule your run? Yes, 6.608 is in the database. So I guess the times are like that. I don't know if there's dates in this file or not, or just times. Would you like to race at that time? And so I asked them that. Once it finds their time, they said yes. And it says, thank you. We have scheduled you to run at 6:08. So it's kind of like golf, I guess. You pick a starting time and they spread you out. So put pseudocode, heading, name, date, purpose. Use comments throughout your program just to show what each section does. Be sure to indent things properly, meaningful names, and it runs successfully and produces output something similar to this. Doesn't have to be exactly this. In fact, it shouldn't be exactly this. Have you put your own little flair on there. And we have our questions at the end. All right, guys. This is the fun stuff. Now we got to put together the last few lessons, look at how to go pull that and see what's in this file. All we know is there's this sun_data.csv file out there, just filled with information, waiting for you to dig into it and figure out how to search through it. So it'll probably take somewhere you would run the program just looking at everything in the file first, and then modify the program to go back and just pull out the data you need. So, because we had programs in past weeks where we just printed everything in the file. Well, that's part of researching what's in there. You have to print everything in the file and then go back and modify. Okay, now that I know what's in it, let me see if I can just search for specific times or dates or whatever you need in there. So, all right, if you get stuck on this, want some help, I'll be in class Wednesday, or you can email me. We can set up a time. But this should be a little more challenging, a little more fun, because we don't really know everything at this point. We don't know what all's in this file. A little exploring this week. All right, guys, if you don't have any questions, I'll let you go and start digging into some data.